Hello Twitch, hello YouTube, hello world. So we are here again with one more episode of building Gameboy Emulator with Rust. Yeah, and so I did some tests. I think we are good with the sound. Let me just get this screen here because it's too far from me. Yeah, I think that is good now. Yeah. And the phone actually is. Can I send it away? Yeah. Just oh yeah. So I think now we are good to go. Oh, hello, Ellie, D. Yeah, the chat is so far from me. Let me just. I think What? Yeah. So Ellie base 314. How are you doing? So you are a Rust programmer. Used to play with Rust. Z8 simulator. Yeah, Z8 emulator it's close to Game Boy. There's some instructions that are shared between them. So I think you did something that we are not doing here. Yeah. So I really enjoy playing with it. Yeah, they are super similar. Yeah, they are similar. Yeah, Rust it's used to be the most loved language to work with, at least on the on Stack Overflow surveys. It always like let me see here, like Stack Overflow survey. If you see here, technology and most loved, yeah, Rust is the most loved every year. It's very nice to work with. With Rust. Yeah, Python is close to that, but well, Rust it's better. It's even better. So let me put this way, or at least this way. Yeah. So now let's get back to our Oh yeah, and let's put some music. So let's get back to our Rust. Back to our Rust emulator. And yeah. So yesterday we did this. So as we saw, the Nintendo is working, but it got failed when it reached this instruction. And if we go to F3, F3 is a DI instruction, which is which is I have it here. So let me open. Okay, so the DI instruction is these instructions disable interrupts, but not immediately. Interrupts are disabled after instruction after DI is executed. So yeah, it's we need to have these interrupts here to these instructions made sense. So let's get back to that article. Yeah, here we have this article about the interrupts. Hey Dan, how are you doing, man? Today we're gonna start implementing the real stuff, like the interrupts actually. So, and how are you doing with your emulator? Any progress? I think you didn't. Did you share with me the GitHub address for that? So let me see here. If we can click there. Oh yeah, you sent me the macro stuff. That was like a gist, right? Not a, yeah. So yeah, I will take a look on that macro. Yeah, I knew that I need to start something that you told me. I will definitely work on that later. This week is I'm very busy with the work, but anyways. So we are at the time to implement Rust. Sorry, to implement interrupts in Rust. Yeah. So what are interrupts? So this description here is very good. So there are two ways for CPU get something that it's external or it needs CPU attention. One is pulling, so it's kind of every instruction we need to go there and check if something gets arrived for CPU to process. In this case, it's a network card. So in this case of explanation, but interrupt is different. It's kind of it's reserve a specific address which the processor will always pay attention on it, of course, in every instruction. So it's the only thing that the CPU needs to do is check that specific address, specific register, and if there is something there, it jumps to a specific instruction that is already in the memory, which will handle that interruption. So this is kind of how this should work. Remember that we already have our run instruction. So run. So here in our run instruction method, we have the fetch, decode, execute loop. This is the most important part of a CPU. Okay, so this is here: fetch, instruction, decode, the operation, execute. So when we implement interrupts, it will be like a new step on the process where we will check if my macro stuff is very slow to compile though, because of the code changes. Oh, then. Yeah, I never used macro with Rust, but yeah, it generates code, so it will probably be slow to compile. I mean, it's slower the compile process, but as soon as it gets compiled, I think it gets fast, right? I mean, the other compilations should be good. So getting back to interrupts, so instead of pulling and checking what needs to be doing, actually it only check the interrupt address, and then if there is something there, it set the program counter to go to that ICR, which standard for ICR is interruption interrupt service routine. Yeah, so because what it should be doing is like our program, the program that the CPU is executing will put some routine or some function in a specific address, and that function will be used to handle that kind of interruption. So let's say that I'm creating here a network processing. Okay, so if the interruption, if I want to handle that interruption, I need to put a specific routine on a specific. I need to put a routine in a specific address in the memory, which will be the interruption service routine. And then, when every time a processor sees that there is an interruption coming, it will jump directly to that address to execute that routine. So that routine will be only executed if there is an interruption, and that will be fast because the CPU always know where it should go exactly to execute that routine because it's predefined. So here we have, for the Game Boy, we have five ICRs address. One to handling vertical blank interrupt. So when a vertical blank interrupt get into the CPU, I will execute the code which are in this address. The same for LCD status trigger, time overflow, serial link, joypad press, and so on. The most important here for us, I think it's joypad press, the LCD and vertical, and probably timer. I don't know if Tetris uses timer. The serial link is only if we implement the serial link function, which is the like put together two Game Boys. We will implement that in the future, but not now, so don't need to worry. And how the CPU knows if it needs to go there and execute that routine? There is something called interrupt flags that oh yeah, sure, I will definitely look into yours then. Actually, so that's something I don't know if I get your GitHub address or just gist address. But anyway, I will ask you, and then I will take a look in your implementation as well. Yeah, sometimes I do look into other Rust implementations, but I'm kind of avoiding that just to understand to implement from the documentation, just for me to get better understanding what I'm doing and so on. Because if I go to the code, see others' code, sometimes I feel like I'm cheating, you know. So I don't look too much in other codes before I get my implementation. But I will definitely check it out later. And also, talking about the future of this streaming and so on, I will be doing. I'm still choosing what should be the next project. Of course, this Game Boy, will take much more time. But what I'm planning is this: when I reach the point, for example, to be able to play Tetris, let's say Tetris. If I'm able to play Tetris in my Game Boy implementation, I will not stop the Game Boy project, but I will do something like 2 days in the week. I will continue with the Game Boy to implement the rest, but I would like to put like other 3 days in some other project. I don't know yet what I will do. I'm thinking about implement some game. I'm actually between two projects. One, a game entirely in Rust, or implementing some full stack web application with Rust. And when I mean full stack is backend in Rust and front end using Rust and WebAssembly. So those two projects is something that I really like to go and check. But as I said, this Game Boy I will go 5 times a week till this Game Boy get in a way that we can play Tetris, and then I will just reduce the time dedicated to it to twice in a week, and then the other 3 sessions I will be doing the other project. I got bored simply writing instructions, and Biscuit in simulator implementation caught me eye to try repeat. Oh, okay then. Oh, I saw that Biscuit implementation. I saw his video actually, and like live coding, but in acceleration mode. That's very nice. Yeah, but for example, in Rust, maybe we also can do instead of macro, we can like do closures and just passing the function to each instruction. I was thinking about that. Maybe that is also good because we can reuse it and compose the functions depending on the other stuff. Yeah. So let's get back to interrupts. So for the most so so as you can see here, we have two flags. Well, that's what I do with macro generate 2. Oh, I see. So you actually doing closures, but with macros. Yeah. Yeah, I don't know. But did you actually run that to see if that is fast enough? Because we still have this slowness issue in my version here, which I need to check. Because even that we are getting this to this Nintendo logo to scroll down in reasonable speed. I think it's not a full speed of Game Boy, and even more, my machine is much better than the Game Boy. It should run faster. I am not handling any kind of timings here yet. Prefix CB prefix opcodes have a clear mnemonic, so I decided against generating functions for all. Oh, I see. Yeah, the CB, I know that CB stuff are like, they have something that we can share code between all of them. Yeah, for here I'm still doing that way, which is kind of verbose. But I don't know if this is lower the thing or not, but it's more verbose. Yeah, it should be very fast. Mine too, I mean, I don't think that this should be too slow, but it's still something that I do not get why it's too slow. So let's get back here. So we have two kinds of flags for interruptions. One is if I can, if the interruption is enabled. So if any code can enable that interruption, can set that interruption. And other one is which if that it means that the interruption is activated. So yeah, so I think we just need to implement. This will be inside the CPU because the CPU is the one that's responsible. I have a jump table What do you mean by jump table? You don't go directly in every record of the memory? I mean, your memory is not. I didn't get the jump table. Jump table. What's the jump table? I will take a look into this. It seems nice. I need to understand better how. I got. Oh yeah. Yeah, that's something that I was thinking, because for each instruction I am doing at least 2 comparisons. Yeah, because one is translating into the instruction and then matching again. Yeah. That is also something that I can check later. Yeah, I can like call the function directly here or something like that, and then that will probably make this faster, because at least a little faster, because for each instructions, well, a double faster actually, because for each instruction there will be less comparison. Yeah. That's nice. That's a good way. Of thinking. Yeah, definitely I need to have factored this for. Yeah, and also this register name here. More comparison and comparing string. This is guaranteed that that's lower, because I am not in, I'm indexing by string. I should have at least a hash map here, which probably much faster than this. But well, let's see. Let's continue the implementation and see, because that slowness which we had was mostly not because of this, but because of handling the screen itself. And now we are just handling that in specifically moments, and only if there is something new in the VRun or in the viewport, which is pretty good. Of course, I can even go even further and do more about that, but I think for now it's okay. Let's go and check how I should implement this. So I need to First, I will need to get let's see CPU. So I will get the so you have a function here that get interrupt enable. I think we call this IE. Oh, we have the IE, the EME, okay. I think let me see here, Gameboy Emulator register. So yeah, we have this IME, interrupt master flag, the interrupt flag. So there is this flag, and where is this flag? Oh, see, actually that instruction, the DI, is just to disable this EME flag. Okay, so it's kind of, we have an internal interrupt on the CPU. It's kind of a register. Yeah, so the master flag is something inside processor. We can actually implement this as a record. So EME, and it will be Boolean. It starts as false. So, and it will start as false, and well, there is only two ways of setting that. I think we can go directly and implement that. So let me go here. So we have this instruction. This instruction disable interrupts, but not immediately. Interrupts are disabled after instructions, after the IE is executed. Okay. So I actually need to... No problem. I will just use this as a... Yeah. So I will... Maybe I will... I'm falling the temptation to not implement the entire interrupts yet. So let's do this and AI. And go to the code. I will do something like this. Instruction, DI, and FB. So now we are decoding. And here this instruction is simple. So DI, it simply turns self to false. Wait. AI turns it to true. Let's see how many. Four. So it's just one. Okay, so let me put both. Yeah, it's almost equals to. Yeah, of course this all this stuff could be reduced. So I can do this. Yeah, so we are not actually implementing the interruption yet, but we are implementing the master enable flag, interruption master enable flag. So now we are able to... What's that? So this is this. Okay. So here we have still have a problem here. Okay. So now let's see. We implemented the DI. Yeah, it failed. So 36. 36 LDHL. Yeah. Why we don't have LDHL? Don't have this. LDHL. So how this is. So we should load. I think this is a. No. Here we have LDH. So what is 36? Here. Oh, this LD. So I think we already have that, or something like that. It's this LD. Okay, so let me put something. Okay, so we put like LDHL. This time is LDHL U18, which are different. That puts this way. So also I will do something here. To be LDHLN with N1 as U8. Okay, so then we we're gonna okay, so now let's implement it. I will go to LD like VA. Okay. Yeah. And how this works? So get the register. And how it works, put the value R2 into R1. Okay. So in this case, I will put. So I need a like HL here, which will be something like this. I have a lot of codes that could be problem here. Okay, I want to, yeah. So now I just return self. No. Oh, this get register do not receives. Oh, no, I will just implement this. I will implement it here, like instruction. I will not use this. So this is HLN. N. I will just get. Yeah, I can do this. Okay, so then I will do this. I have HL. Then I will let. Content equals to byte from HL, and then oh wait, actually it's the reverse way. I will do it's simple. It's like write byte put value. Oh no, sorry. So this way, I just put directly the value. So it's write byte. The address is HL and the value is N. Actually, yes. So let's see. More. So 36. Oh. Oh. Okay. Let's see if we have any. Well, it's still there. Something is wrong. So let me do something that is the same. Okay. Well. I think somebody else already disassembled Tetris, which is good because now we can see what is going on here. We'll just stop here and I will go to our I will put here after we get into the loop. Let's see. Well, we are probably in loop already. Okay, so let's see. We have program counter at 250 and the instruction is still LD. Let me check here. Yeah, this is an LD. Yeah, let's continue. Oh wait. Yeah. Of course, my horse. We forgot to increment our program counter, right? So self PC equals to self T is plus equal 12. Self M is plus equals 3. Now we are good to go. Okay, it will probably fail in the next line because there is other loads there that we didn't implement. Yeah, it failed. 2A is 2A. Yeah. Load A HL plus. Load A HL plus. This is, I think I already implemented something like that. Here, L, D, A. I implemented the other way around, which is I already implemented, but it's this. So wait, LDH HL plus 2A. Oh yeah, implemented this one. This one is put A into memory address HL and incremented HL. This is put a value address into A and incremented HL. Okay. So I go to this. Then this. Okay. So first I will do okay. It's just the other way around. And then I'll call this. And this is okay, so it is okay, so put the value at the address HL. Actually it is different, it's self A and sorry, itself A equals to byte HL. That's it. And then increment HL. Okay. It's 182, yeah. So we are fine. Let's see. Fail again. 0B. 0 B. Decrement. So it's it should be around here. Oh. There's something weird here. 279E. Oh yeah, yeah. There should be any jump here. It makes our and we go here. We go to this BC. And we are starting loading something in the screen. Actually changing the tile map, right? Because we are filled this area, which is our VRAM. Right. So let's continue. Yeah. Well, I will do a little stop for today. I need to go out to dinner and I have some work to do. yeah, this I read the find that this weekend I will do streaming like on Saturday and also on Sunday to recover all this time that we are losing during the week. But this weekend I'm far from home, so I will be coding in the weekend. So I during the week I'm probably not having time for doing 2 hours of streaming, maybe on Friday. But yeah, let's just wait for the weekend. Then I will do a bigger streaming. But for now, I will stop for today. I will just yeah, we just implemented some other stuff. We did not implement the interruption yet, so I will just add this. Implemented more opcode. And yeah, thank you for watching. I will be back tomorrow, maybe with more time, and let's see. Thank you everybody for watching, and see you tomorrow. Thank you.